Hello everyone. During this COVID crisis, everyone is stuck at home and all teachers are making videos and posting on YouTube and other sites so that they can help their students. I'm also making this my first video for my students, and today's topic is probability. So its chapter is probability, and the topic today it will be random variable. So I'm going to start random variable today. So random variable. In this topic, we will understand what is meaning of random variable in probability, what is its applications, and we will also learn related concepts. So first definition. Random variable is a real valued function which connects each outcome of an random experiment. So before we understand random variable, it is must that we should have a random experiment. So let us take an example. So I take first example. The random experiment is two coins are tossed simultaneously. So now, if two coins are tossed simultaneously, then what will be the outcomes? It can be both the coins head head, one coin head tail, or it can be both tail tail. So outcomes are head tail, tail head, head head, tail tail. Once we have the random experiment and its outcome, we must define random variable. So random variable I'm defining here is number of head or heads in the outcome. So now let us take one outcome and then see what is the value of that random variable. So I first take HH. How many heads? It is, I can count two. Then if I take head tail, how many head? One. If I take tail head, I again see one head. And if I take tail tail, this is 0 heads. So these are values of random variable for this random experiment where X is number of heads in the outcome. So this is how we define random variable. So we can see very clearly here, each of the outcome has been associated with a real number. HT associated with 1, TH associated with 1, TT with 0. That's how we see here. That's how we define random variable is a real valued function which connects each outcome of a random experiment. It must be, I missed this, with real numbers. Now, Let us take another example. Another example. Again, we must have a random experiment. So let us write a random experiment. Now I see, say, 3 coins are tossed. So what will be the end? We must define what is the random variable. So random variable is number of tails in the outcome. So let me write outcomes. It will be head, 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 tail, head, tail, head, then tail, head, head, then head, tail, 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 head, tail, and then tail, tail, head, and last it is tail, tail, tail. So how many outcomes I can see? Sorry, how many tails in that outcome? This is 0 tails in this outcome. How many here? It is 1. How many here? It is 1, 1, 2, 2, 2, and here 3. So here I can see random variable x can take value 0, 1, 2, 3. 0, what are the outcomes which has random variable x equal to 0? It is h, h, h. This one, it is h, h, t, h, t, h, t, h, h. And for 2, it is h, t, 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 h, t, and h, t, t. And for 3, it is all tell t, t, t. So I can very clearly see each of the outcome has been assigned a real value, or random variable x connects each of the outcome with a real number. Now I'm going to define next concept, that is probability distribution function. Each value of random variable is associated with outcome or outcomes of a random experiment. Based on the probability of outcomes, we assign probability to each of the values of random variable. This assignment creates probability distribution function. What does it mean? So I'm copying this random variable x is equal to 0, 1, 2, 3. So this example is, what is that example? 3 coins tossed. And what is random variable? It is number of tails. So for x is equal to 0, what will be the outcome? That is h, h, h. And what is probability of h, h, h in this random experiment? It is 1 by 8 because total sample space is 8 here. And favorable is only one, that is h, h, h. All three are head. So it will be 1 by 8. So it is probability of x is equal to 0. For x is equal to 1, what are the outcomes? It is head, head, tail, head, tail, head, and tail, head, head. Here I can see 3 favorable outcomes, so probability will be 3 by 8. For x is equal to, what are the outcomes? H, T, 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 H, T, and T, T, H, and nothing else. So it is again 3 outcomes, probability is 3 by 8. Now x is equal to 3, what is the outcome? Only one outcome, it is T, 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 that is 1 by 8. So I can see here with each random variable, x is equal to 0, probability is 1 by 8, for value x equal to 1, it is 3 by 8, for x equal to 2, it is 3 by 8, and for x equal to 3, it is 1 by 8. So let us chart it. So x, and this is probability of x is equal to xi. X is equal to 0, probability is 1 by 8. X is equal to 1, probability is 3 by 8. X is equal to 2, probability is 3 by 8. And x is equal to 3, 1 by 8. So this is the table for probability distribution function. Here, two important things we need to remember. Probability of each random value, that is for 0, for 1, 2, 3, it will be different for different random variable. But right now, I am seeing this example. For 0, it is 1 by 8, for 1, 3 by 8, and likewise. So for each random variable value, probability must be between 0 and 1. So no probability will be negative or more than 1. It must be between 0 and 1, where 0 and 1 should be included. And another important thing is certainty is 1. So here 1 has been broken into 4 parts and distributed with all values of random variable. So sum of all probability will be 1. So probability of x is equal to x1 plus probability of x is equal to x2 dot 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 till probability of x is equal to xn, it should be 1. So these two things are very, very important. These two things will help us to decide a given probability distribution function is valid or not. For that, I'm taking two simple examples, and let us decide, is it probability distribution function or not. First example. So this is where I'm going to create a probability distribution function. This is x, and this is probability of x is equal to xi. So x is equal to 0, 1, 2, 3. Probability 0 0.3, 0 0.1, 0 0.5, and 0 0.2. Question is it a valid PDF, that is probability distribution function? Answer is no, it is not. And what is the reason? If we add if we add all the probabilities, what is the sum? I can see 0 0.3 plus 0 0.1 plus 0 0.5 plus 0 0.2. It is 1.1, which is not equal to 1. So it is violating the second situation. So it is not a probability distribution function. Let us take another example. X, and this is probability of x is equal to xi. 1, 3, 4, 5. Values of this random variable can be anything. It depends on the random experiment. So I have just taken some arbitrary values here. Probability is 0 0.1, minus 0 0.2, 0 0.8, and then 0 0.3. Again, the question is same. Is it a valid PDF? So to answer that, when we look at probability of x is equal to 3, it is negative, which is not allowed. If you add all the values of the probability, its sum is 1, still this is not a valid probability distribution function. Reason being is I am getting probability for a certain value of random variable, it is negative. So I think we got what is random variable and what is probability distribution function of a given random variable. So till now we have learned what is random variable and probability distribution function. So now I will be moving to next one, that is mean of a random variable. So let us start with mean of random variable. Mean, what is mean? Mean is same as average value of random variable. Means what? Everyone knows what is average. So if I take 1, 2, 2, 2, and 3, 3, 3, 3, 3. These are the numbers, and I want to find average of these numbers. So what is average? Average will be 1 into 1 plus, or wait, just I will use another colors. So okay, first let us write it, then I will color it. 1 into 1 plus 3 into 2 plus 5 into 3 by total 5389. This is average. Everybody knows the concept of average. So now let me mark this with different color. So I'm marking this one with different color, these three with different color, and this is what? This is frequency actually, and this 9 is total number. Now I can write this as 1 by 9 into 1 plus 3 by 9 into 2 plus 5 by 9 into 3. Each first term 1 by 9, 3 by 9 and 5 by 9. These are respectively probabilities of 1. Why probability is of 1? Probability of 1 is 1 by 9 because I see total 9 items and this is 1. So probability will be 1 by 9. So this is probability of 1 into 1. Now what is here 3 by 9? 3 by 9 is probability of this 2, 2, 2. Why it is? Because they have 3 and total is 9. So probability is 3 by 9 into that is 2. Similarly, probability of this is 5 by 9. So 5 by 9 into 3. So I can see average is here what? Average is kind of probability of x is equal to 1 into 1 plus probability of x is equal to 2 into 2 plus probability of x is equal to 3 into 3. This is average. I see probability terms because we are dealing the chapter probability. But when you do general average, you don't write like 1 by 9 into 1. You just end up here and get the values after solving it. So what I see here, average, which is same as mean. So mean is kind of sigma xi into probability of x is equal to xi and I is equal to 1 to n. So it is sum of product of values of random variable and its probability. This is mean. Now mean is denoted with x bar. So it is what? It is mean of random variable x. So if I write, formula will be x bar is equal to sigma I is equal to 1 to n xi into probability of x is equal to xi. This is the formula for mean of any random variable. So now before ending this video, I am going to take one question from the beginning where a random experiment will be given and random variable will be defined. So what I will be doing from there, I will write probability distribution function and then find its mean. So let us start with a question. So let us take this. Two dices are rolled. Random variable x is defined as larger of the outcome. Find the probability distribution function and also find mean of x. So first we must understand the random experiment. Random experiment is two dice are rolled. Okay. So outcomes will be 1 1 1 2 1 6 2 1 2 2 2 6 kind of. So total number of outcomes will be 36. Now it says what is x? X is larger of the outcome. So we must make a chart. So take x is equal to 1. When larger is 1, this means both must have 1. So here larger is 1. If larger is 2, outcomes possible are 1 2, 2 2, or 2 1. Only 3 and no other. Because larger should be 1, so other will be either 2 or less than 1. So 3 choices. Go further. Let us start with x is equal to 3. For x equal to 3, outcome will be 1 3. When it is 1 3, yes, larger is 3. So we are focusing larger should be 3. 1 3 2 3 3 3 3 2 and 3 1. Similarly, x is equal to 4. It is 1 4 1 sorry 2 4 3 4 right. X is equal to 5 1 5. If you see, we got a pattern actually. And x is equal to 6 1 6 2 6 6 and then 6 1. So if I make a chart of probability distribution function, so it is x and it is probability of x is equal to xi. X is equal to 1. What is how many outcomes? For x equal to 1, only one outcome. So probability will be 1 by 36. For 2, I see 3 outcomes 1 2 3. So it is 3 by 36. For 3, it is 5 by 36. For 4, it is 7 by 36. For 5, it is 9 by 36. For 6, it is 11 by 36. So this is the probability distribution function of the random variable given. Next question is mean of that random variables. What is the formula? It is sigma xi into probability of x is equal to xi. I equal to 1 to n. For this one, what will be the answer? So 1 into 1 by 36, 2 into 3 by 36, 3 into 5 by 36. Multiply and then add them. So it is 1 into 1 by 36 plus 2 into 3 by 36 plus 3 into 5 by 36 plus 4 into 7 by 36 plus 5 into 9 by 36 plus 6 into 11 by 36. So what will be the answer? You do the calculation and Find the answer. So the answer will be 161 by 36. This is mean of that random variable. So today's lecture, I will stop the theory part here. In this video, I tried to define what is random variable. Then I defined what is probability distribution function, and then in the end, I did mean of a given random variable. These three things we did in this lecture. In the next lecture, I am going to bring next part of the same topic, that is variance of a probability distribution function. So guys, if you did like this video, please like it and subscribe to my channel. Thank you.